In case anybody's interested, never seen it done before, we're going to knock out that 44 tooth gear with a 3D printer. So this is a Prusa Mini. Right here, really small footprint, about a 7x7 build plate, which means 7 inches wide, 7 inches high, 7 inches long. And it is going through its preheat right here. If you can hear, there's some fan noise off to the side. I have a print dryer going, but you can tell that the Prusa itself is very quiet. It's setting up through its initial height check, which it does every time, which I'm thankful for, and it takes a lot of the guesswork out. And it's going to finish that up, and then it's going to start to print. You'll see a little dusty chalkiness here. That was relative to I was doing some PTEG, and you want a barrier in between your build plate and the other, which you might also know it as glue stick. It sets just enough of a barrier there to allow it not to stick, because it can actually adhere so well that it pulls your surface apart. So from that one, she's getting ready. She's doing the preheat. We're starting off at 225 degrees Celsius. That'll be the initial, and then I drop it back a little bit as we start printing. The bed temperature currently is 70. I like to start out with a nice hot bed. Get a nice print down, and then once it starts building up from there, it does pretty much all on its own. It should be coming up here any second now. It's going to do a little purge, and then it's going to start out. There you go. There it goes. Just doing a wipe. Get any junk off of the tip that may be there from the leftover. You can see that. The print filament. Right there, it did its initial laydown. Now it's going to start the perimeter. You hear very quiet. Like that a lot. When you get older, the age, now it's doing the spline. And again, this is just the first layer. There'll be many layers. I found a setting that was wrong. Inside, it was doing a very precise first layer cut. I adjusted that. Now this print's going to take approximately 2 to 3 hours, which is far more reasonable than 15 hours, 12 hours, whatever it was. So you see how it's basically bringing that spline right to life. Oh, that's a lot of work saved. Okay, well, I'm just going to kind of get the first layer down here. It's going to do 10 around that spline. Then it's going to go out and start working on the rest of the print. Battery's about dead in the GoPro, but there's plenty of time to see a lot of this go on, and I'll probably do a time lapse. Okay, right there you're starting to see the very first squiggles going around the outside edge. It's going to build it up, and it's going to head on out and start towards the teeth. I'll be out of battery by then, so. Okay, we will let this get going, and we'll bring you back. I have a very tight tolerance on the first layer, so the plastic needs to go down flat and be squished. There needs to be a squishing to it. If you leave it just as a standard plastic bead, it's not going to adhere very well. So you're starting to see it right now. Building the outer perimeter. It's already done the inner splines at one level. And again, there will be 10 millimeters worth of levels there, and I've got it set up to build it pretty heavily. So there is 10 solid layers before it gets to infill, and there'll be 10 solid layers at the top when it gets done with the infill. And now you can see it's starting to do the teeth. Very uniform. Don't really have a lot of stringing. Now I apologize for the fan noise over here. I'm running a dryer that's actually printing to the printer while it's drying it as well, so causing a little bit more background noise, but you can see the teeth are actually being formed right there. If you've ever ran an indexing head and done these by hand, it's like, okay, Well, one thing I don't have to do when I do this is I don't have to count teeth all morning and hope I don't make a mistake and ruin the gear blank and have to start all over. So that is one plus. They're never going to be as strong, they're never going to be as durable, but man, if you just need a quick one, it sure is a nice way of going about it. Okay, we're going to let it run, but you're starting to see a gear forming there. And we currently have 2 hours and 40 some minutes left in its estimated time. It's usually pretty dead on. And the G code that we're talking about, that's the instructions that tell the printer what to do. Other than that, it doesn't know where to go or what to do, so the G code is the instruction that slicers provide to allow it to know where to go and how much plastic to lay down at what temperature. So right now it's doing the first layer. It's laying it across flat. Kind of see right there, that will be the base. This is where most of the majority of my failures come, is that first layer adhesion. But this little Prusa Mini is very, very forgiving. Once you get the squish set on your initial height of your nozzle, it does a pretty darn good job. Some filaments can be very finicky, but this seems to tolerate them very well. As I mentioned, this is not the cheapest. This comes out of Europe and you got to pay shipping and destination and stuff, but boy is it really refined. I have one out of China, a very big one. It works okay. It is not in a league with this one. I am not endorsed in any way by Prusa. I'm just a happy consumer, and it seems to work out very well. So you can see that first layer is going down, and once that's done, it'll start to just build until it's done. We're about halfway done here. You can see the outer edge where it raises the next level, goes out and completes it. And again, we're doing 10 vertical shells around the outside edge, and we have 10 horizontal shells to start it off. So the infill is really well supported on the exterior by the vertical shell as well as the horizontal shell, so should be very, very sturdy. And it looks like we've had really good luck today, minimal stringing, so we're doing pretty good. So we'll bring you back when we're a little closer to complete. Okay, right about now it's transitioning from the infill and going back into the solid layers. It's going to be a bit yet, but you can see it's laying just basically quasi-horizontal ridges across there. So the infill was going and going and going, but it only needed to be 40%, and I've got a ton of, well, basically 10 layers on top here, so it gives you an idea of roughly how long it's going to be. It's about 45 minutes left, but you get an idea of what's going on inside these prints. So, well, we're all done. Just in 2 hours and 47 minutes. I haven't let it cool off yet, but you can see that looks pretty good. Top surface finish. First experiment using a new dryer that I've got, and looks like the surface finish looks pretty good. Let me show you the beauty of the magnetic base. So this is on a magnet, like a soft magnet sponge, and this metal sheet comes up. So from there, I'm just going to give it a little tweak. Okay. Yeah, you can see it right from there, so it's popped off clean. Bottom surface looks fine. I mean, you can see a little chalkiness from the glue that I had there. But overall, the gear looks really good. Let me get it over here and look. Okay, there it is. Sorry, bumping the camera here. Just a little bit of more light here, as you can see. I know it's dark in the basement, But you can see the surface finish there. You can very easily see the ridges where I put all those crazy levels of vertical rows in. You can see the same around the outer edge for the gear teeth. And actually, this is a beautiful print. No stringy, no nothing. Notice the edges are nice and crisp. Even in the teeth profile there, you can see those layers where it went layer by layer by layer, which is, of course, that's how they do their business. However, the proof is in the pudding, if you will. So let me bring out 40 tooth here. Nice. Okay, bring it around like this. Okay, if you can see that right through there. Nice, beautifully smooth gear meshing, no clunking, no grumpy, no nothing. Looks great. Lining up the inside profile, we've basically matched the spline. You know, at visual you can see that it's pretty darn close. Looks pretty good. And from that, we were able to create that from nothing. So, okay, give you a little backlighting there. You can see the mesh there, looks really good. I mean, it doesn't bottom in the root. If I square those up, it's got a little bit of clearance, but looks pretty darn good. So moves smoothly, so we're in good shape. That'll be a good shot right there for you to see. Okay. All right. We'll see if we can get it on the lathe a little bit and bring you back. Brand new gear. Right here's my main drive that I'm going to be putting it on. This is usually what it is. So here we have the initial. No pre-fit now. This is straight up. Okay. Nice, snug fit. Not having to bash it or anything like that. Probably can have just a little more clearance, but I would rather it was like this than flopping around. Okay, just that little bit of force from the nut. Got it right on there. Looks good, feels good. Yeah, let's send this down. All right. Okay. Normally I'm going to take a piece of paper in between the two. You can see right there, this is the phenolic one. It was on there before. Mesh is good. I mean, I'm not really setting it difficult there, but I don't see anything wrong with that whatsoever. So, there's a 44 tooth. I've had different luck. You see that one there? I had to do some more shaving. So this is where you got the experience of me futzing around with those numbers. This was a horrible print for some really wet filament. Here's another one I did, slightly better. This is PTEG, and it came out fine. But I think, as of this one, now this one I got cute. Actually modified the design a little bit because it's getting very, very small. And the stringiness of this thing, I actually built another layer on the backside that's bigger than the splines, but gives it just a little more outside rigidity. But again, that's pretty small. It'd probably be best made in a physical metal, and that wouldn't take long. But yeah, that's how bad it can be. And you notice all the futzing and all that I had to do. That's why I went with the dry one today. And if you noticed, This one we printed today, it had virtually none of that nonsense. Okay. Yeah. See, we had none of that nastiness. You'll see when it went on, just the slightest bit. So I can't guarantee the size dimension is going to be perfect for yours, but I can say that on mine that's pretty darn close. I could probably have went another, I don't know, 3/100ths of a millimeter, maybe 5/100ths of a millimeter, and got that just to slide right on. But I'm perfectly fine because that plastic is going to displace where it needs to a little bit. Again, I mentioned in the sub notes, do not bang on these things, okay? And you fit it one spot, you may have to do just a little bit to get it on the rest of the way. Okay, I think that is about it. So thanks for watching, and I did this kind of in two pieces. I wanted to be able to show the product output, but also wanted to show you how to do it and not make them, you know, overly long video, which I typically do. So, all right, thanks for watching, and we'll bring you back for the next project.